Yeah, thank you, everybody. Let me see. Can I restart this? Yeah, so we're gonna learn Rust today, and I'm pretty excited. Real quick, show of hands. Who here has programmed before? Who has done any Rust before? Okay, okay. Who thinks they're the dumbest person in this room? Okay, awesome. All right, I'm gonna lean heavily on the dummies, because I really there's a lot to Rust, and I think we can actually learn a lot by what we get stuck on, and we can focus on what we get stuck on, and try to figure it out, because we're not going to learn everything you need to know about Rust today, but if we can get a relatively strong understanding of a few concepts, I think it'll be helpful going forward for learning. Yeah, so I guess I should introduce myself. I'm Paul. I'm a front-end developer, so I'm the last guy you want teaching you about Rust. Rust is actually one of my first it's the first open source pull request I ever did was in Rust. I just got really interested in it back even before the 1.0. Especially really resonates with kind of the Bitcoin ethos. Like, let's build something for the long term. Let's build something that works. Let's, be aware of the trade-offs we're making. And yeah, so this is the tagline from the Rust website. What is Rust? Rust is a language empowering everyone to build reliable and efficient software. So what does that mean for me? So Rust is bare metal. It doesn't have a runtime or a garbage collector like some languages you might be familiar with, like Python or Go or JavaScript. So the code runs fast. You can get just as good performance typically as like C++ or C. The code runs anywhere. That lack of runtime makes Rust highly portable. Like, I'm working on a Bitcoin wallet that works in a web browser, and we're writing the core logic that in Rust. Rust also has this really cool emphasis, and this is a big differentiator from C, C++, at catching bugs and errors at compile time. Things that in another language you might be fine and you can ship to production. In Rust, you're just going to be still stuck trying to get them to compile. And that can be really frustrating in the early going with Rust, because like, well, this would have worked in a normal programming language. Why does this have to be weird? But this ends up being like the thing that you're really grateful that Rust that helps you with. And also, it has really modern tools and ecosystem, which it's just really nice to work in. And there's a lot of emphasis on ergonomics. It's got a package installer, a lot like NPM. It's got testing built in. It's got great IDE support. So that just makes it, nice to work with and relatively nice to learn. So how do I learn Rust? Like, we're going to try to learn as much as we can here, but I definitely want this to be a jumping off point. So sadly, you got to read this book. And lots of languages have a lot of different approaches to, yeah, we got a question? Yes, sadly, you might have to read this book multiple times. That's a great point. There's just a total consensus that this is the first stop in learning Rust. There's a book that is kept in line with the latest in Rust, and it's a really good path because there are so many concepts to Rust. It takes you in a relatively linear path through a lot of those concepts. It won't be everything you ever need to know, but it's like a really important way to start. So definitely recommend it. It's called The Book. Some other ways, if you have different learning style or you want to augment that, somebody actually made a huge project of, it's called like, it was designed for Rust in like a simpler English. So like people who might have English as their second language might struggle with the Rust book. And so somebody made this thing, now they call it Easy Rust, I believe. And then somebody else made, or maybe the same person made a video series, like Rust in a series of lunches. And there's a video for just each concept in that. So if you're a more visual learner, that's a really great resource. If you like example-based learning, I really enjoyed command line Rust. I actually haven't finished it, but as far as I've gotten in it, it's already been really enjoyable. So I think that's another great way to learn. And then there's a lot of writers in the Rust ecosystem that kind of tackle some of the harder problems. Faster Than Lime is one of those really good writers, and he's got a half hour to learn Rust, which sounds optimistic, but a lot of it's just about exposing you to a lot of syntax, because you're going to see a lot of things that don't look like your normal programming language, and your eyes are going to glaze over, and you're not going to know what you're reading. And the best way to learn, how code works is reading. So learning how to read Rust is going to be very helpful. I also really highly recommend, it's very common in the Rust ecosystem. This is a screenshot from BDK, which is what we're going to use today, which is a Rust Bitcoin development kit. It's very common for Rust projects to have an examples folder. And so you can clone a Rust project and then cargo run example, whatever the name of the example is. And so going into GitHubs and reading the examples of how the library author expects you to use this library is hugely helpful for learning Rust in more practical ways than just, the more basic tutorial stuff. So yeah, recommend that. And yeah, I just want to, maybe this is a lot of preface, but I'm trying to set some expectations. I think it's really common with Rust. The first time you see something, you just don't like it. Like, I just don't like that Rust does that or makes me do that. So like, that's this kind of sucks stage. And then you kind of find some sort of hacky way to do something, but it doesn't quite feel right. And you start to wonder if there's maybe a more idiomatic solution. You start Googling it. And then you learn about that there's a nice idiomatic way to do something. But the last stage is that you've kind of have that memorized, that's internalized, and now that's easy to you. And so there's a lot of concepts in Rust, and there's this hump will kind of recur. So I just want to kind of prepare you for that as you start your journey. You're not alone. And this is more just kind of meta learning stuff. Like, be patient with your brain. Have you guys heard of this concept, the magical number 7 plus or minus 2? So this is like a thing. I don't know why that's loading Figma. I must put in the wrong link. It's supposed to be a link to a Wikipedia page, but this is a concept that the way our memories work, our near-term memories work, most of us can hold 7 things plus or minus 2. I'm definitely a minus 2 kind of guy, so I can hold in my working memory about 5 objects, right? And so Rust is going to try to teach you 20 objects, and you just can't hold that many in your brain. Even if you're a 7, you're really going to struggle. And so the process of learning is becoming so familiar with them that you can compress these objects, and so these 5 things or 7 things that you're holding on to in your brain represent a much larger body of knowledge. And so I think Rust especially is a challenge because of the way our minds work in this way, but you can get past this stage and Rust will start to feel comfortable, but it will feel extra hard at first. I also want to just throw up, along your Rust learning journey, there will be these various things that you're going to run into, that you're going to struggle with and be confused by, or maybe have decision paralysis of like, which library do I use? So we're not going to go into all of these today, but I just want to let you know that these are common things that can be hurdles for learning Rust. Serde, error handling, which web framework do I use? A lot of ecosystems have like their obvious blessed web framework that everybody loves. Rust has a bit of competition in that space. Async is a whole monster. And then there's some like more advanced parts of the language that you don't actually have to use every day or don't have to fight with every day. But at some point, you're going to be doing something that's going to require understanding these concepts. So I'm just kind of flagging these for you. And yeah, I believe everybody, I was trying to let people know before we started, but to get started with Rust, you need the Rust compiler and toolchain. So that's easiest to install rustup.rs. Some operating systems have like a good Rust distribution, but most Rust users seem to just use rustup. And then for IDE support, the popular choice is Rust Analyzer. There's also some IDEs that have their own implementation, like the JetBrains stuff. But I like Rust Analyzer, and I use Rust Analyzer with VS Code and also with like Vim-like editors. Yeah. Oh, and then that's it. So that's all the preamble. So let's just start. Let's start learning some Rust. So what I did is, well, first we're just going to make a new project. So we're just going to make a project called Paul Workshop, or whatever you want to call it. I don't know. So that was cargo new Paul Workshop. So if you have Rust installed, you have this cargo tool, and that's the sort of the package manager. And so when you do cargo new, it creates a new binary application. And you actually, Rust is really nice, and they write hello world for you. Oh no, well, I forgot to cd into the directory. Cargo run. Hello world. So we've already completed hello world, and we haven't written any code yet. So congratulations. Is anybody having a problem with this stage? Everybody's good? All right, so let's open this up. And yeah, let's look what we got. So we have a main.rs. So the main is the entry point for your program for a binary. Rust projects can be a binary or a library. So libraries are designed to be consumed by other projects. But we just made a binary here, so that's got a main function. And then it has print line, which is an exciting, our first weird bit of syntax is there's an, actually, let me make this text just a little bit bigger. We got an exclamation mark. That just means that print line is actually a macro. So it's fancy, and we're not really going to learn too much about it. Just know that it's a macro because it can accept like multiple arguments. So you can say like world, and you can do some string interpolation. Let's say PlebLab. So normal Rust functions don't accept different quantities of arguments, but they do in Rust. Yeah, so what I want to do is kind of walk us through. I'm going to pull in this README that I made. I basically made a Rust project a few weeks ago. Actually, maybe I'll just run this and kind of show you where we're going. Hope this works. Compiling tons of dependencies, 256 dependencies. That's sadly pretty common in Rust. So this is running a web server, and yeah, this is going. So let's open this up. So this is, I call this PayPal. So this is a server with BDK as like a Bitcoin wallet that's generating new addresses off of a wallet descriptor. And it's also connecting to a Lightning node in the cloud running on Voltage to get new invoices. And then every time I refresh, it gets a new address, it gets a new invoice, and then it also puts them together in a unified QR code. And so that's all. So I don't know if we'll get all of that done. Maybe that's a little optimistic. But what I did is I just kind of wrote down what I was thinking, what I was doing at that time. So I'm just going to pull that into here, and we're just going to try to recreate as much of this as we can ourselves. So we've already got step 0 done, where we have Rust up and Rust Analyzer. And so yeah, let's just do step 1. And I kind of hope that I fail at some of this stuff. Yes, go ahead. That's kind of hard to read. So bigger? Oh, the README? I don't even know if that's pushed. These are my notes for what we're doing right now. You don't have to have this right now, I don't think. It's like you could go to github.com/FuturePaul/PayPal. I don't know if I actually pushed the README. Let me do that real quick, actually. Add README. So yeah, that should be at github.com/FuturePaul/PayPal. If you guys want to pull that up. So actually that would be helpful. Good call. So yeah, so the first thing we want to do is BDK. Actually, maybe I should explain a little bit about BDK. Is anybody here familiar with BDK? Okay, just a few. All right, so let's try a new browser today. Great choice. Let's see. We got BDK. So BDK is a modern lightweight descriptor-based wallet library written in Rust. BDK is in turn built on Rust Bitcoin, and this is just one of the this is one of the advantages of using Rust. Maybe the advantage is that you're getting some really good tools built for you the right way. And BDK, I think, is one of those where the thought is, hey, what if we build the part of a Bitcoin wallet that everybody has to build, and we build it really well and in a way that's usable in all sorts of settings. And now, as a wallet developer, which is me, like I don't have to understand or think about all of the low-level aspects of this. I can just use it. And yeah, so they've got an example right here of setting up a new wallet, and so we're gonna do this. But first, we need this wallet descriptor. So let's see. Yeah, so I'm just gonna paste this. Let's see. Yeah. Here I've got. So we got cargo new. We did that. Hello world. So now we want to like read this descriptor like from the environment. So this will be our first Rust logic. So if you go to the Rust book, there's some stuff about oh no, that link isn't working. Shoot. All right, we're just going to read something from the environment. I might have to cheat off my existing logic. There is. Let's make a .env file, and we'll say wallet descriptor. All right. So it's kind of like an xpub plus. So it has an xpub in it, or in this case a tpub because it's a testnet. But it also has like what the derivation path is. So like this is, have you ever seen like walletrecovery.org? Like like all these like, hey, you have the seed words, but you actually don't know enough to actually restore these funds. This is the other part that you need to know, like what kind of address this is. This is WPKH. This is the fingerprint, and this is the derivation path. So if you have all of this, then you're actually good. And so that that's BDK is all descriptor based. I'm gonna cheat a lot more than I thought I would have to, because let's see. I just copy and paste their one. Yeah, if you know how to get your own descriptor, go for it. But I just steal theirs. It works for me because I'm not going to be spending this. Yeah. So what we want to do is we're going to load this environment variable from .env, and there's a library called .env. So if as soon as you want to do something in Rust, let's see. I'm trying to put you guys in my shoes, because I'm in my shoes right now of trying to remember how I did all this stuff. Yeah, so let's, so I know I want to read a file from the environment and get those environment variables. And so I'm just gonna grab a crate. You can, there's a crates.io. There's also, yeah, there we go. So that, so this is a way to like browse libraries, a lot like npm. And this is, I just really heavily rely on Google. But yeah, so what we want to do is we're going to add this library so to read the environment variables for us. So let's go terminal. I'm going to just go just a tiny bit smaller. So Cargo has a command called cargo add, and you can just add a dependency. And now you can see the .env is now in my dependencies in my cargo.toml. That's a lot like a package JSON, basically. And now I can import it in here. And I'm just going to read from the file name. So we want .env from file name. So this is kind of the method syntax, this colon. We're going to read from .env. And now we should have those environment variables available to us. And then we can use the standard library with the env. And what we want? Wallet descriptor. All right. Yeah, actually, well, so let me show you a little bit about this import syntax. So I something REST analyzer, it's on my computer, it's command period. These like quick fixes are pretty helpful for imports. So if you see, it's saying like, so right now we don't have an env in our like current namespace. So I'm going to import standard env. And now I have an env because of this. So now I can use this var method, right? Now I could just, the other way I could do it is, so like it cannot find function from file name. So I have that, you know, I have the .env library, but I don't have that in my current, you know, working area. So what I can do is I can add an import like that. And so what I do sometimes, it's just really kind of a matter of taste, whether to be like really more explicit. Like we could also just do it like that. So we now, but like var is such a like a tiny little function. Like, I don't know, I think I'd rather have it like this, but that's kind of a matter of taste. So sorry if I'm a little all over the place, but yeah, let's explain. Yeah, this so we've imported this method from .env that will look at our env file, and now we're doing our first little bit of we're doing our first binding. So this is a let descriptor. So this is just a normal let in a programming language. And then it's gonna look up what is the envar set for wallet descriptor. And hopefully that's what I did. Yep, I called that wallet descriptor. And you see that I've got some yellow squiggly. This is an unused variable. So we can, GitHub Copilot's pretty helpful. We can print line this. We could also, something I really like to do in Rust is this debug macro. Which will print something out as well. And yeah, hey, we got a first mismatched type error. Let's see. Oh, yeah. So this is actually pretty nice. I didn't put a semicolon on here. And in Rust, if you don't put a semicolon on the last line, it's an implicit return. So I'm saying I'm returning this. And so Rust is mad at me and saying like, hey, I expected the empty type, the empty tuple, which is these parens, but I found a string at the end. And my main function says it's not going to return anything. There's no return type up here. So I'll just fix that with a semicolon. All right, so now if we run this and we panicked, beautiful. So let's look at what happened here. Yeah. Light mode. Is that more readable? Maybe the glare. I think white mode's better. Let's see. Theme. How do you do that? Theme. Can I toggle? There we go. Is that better? All right. Sorry, everybody watching this on the internet. Let me put this in quotes, see if that helps. So I've got wallet descriptor in just in the root in the .env file. So let's see what I did wrong here. Let me try that again. Yeah, it's just not present. So thread main panicked at called result unwrap on an error value not present. So what this compile error actually tells me where this happened. So that was line 8, right? And so I unwrapped something, and what does that mean? Well, so let's not unwrap it. Or let's just try to read this. Like this is how I would probably do this in a normal programming language, right? I want a descriptor. Let's read the wallet descriptor. But now if I try to print that, it says result string var error doesn't implement standard format display. So println doesn't like this result type. There in Rust Analyzer, there's a thing you can get that's called inlay hints. It gets kind of noisy to have them all on all the time. So I disable it by default, but I can like hold this command to see them. So you see this let descriptor it's not, we'd expect this to be a string, right? We're trying to read this environment variable that should be a string, but instead it's a result. And so that is a concept in Rust, and it's a really important concept, so it's worth taking plenty of time on. So result in Rust is an enum that could be either OK or error. And it's generic over the type of the OK value and the type of the error value. And so in our case, this is if we look at this again, this is a result string var error. So have people dealt with generics before? I mean, I know they were pretty new to me when I started with Rust, but that just means, you know, these could be of various types. And in this case, what we have is a string or a var error. And so that means that the OK type is going to be a string, and the error is going to be a var error. And what this allows you to do in Rust is to, at compile time, like I was talking about before, Rust says, hey, you're trying to do something that might not work out. So instead of just hoping it works and putting out in production, I'm going to force you to deal with the fact that this might not work out. And so you need to check if you actually got OK, or if you have an error, you should deal with that error. The hammer for dealing with this is you can just unwrap it, which was what I was, let's see. you can unwrap this result. And that says if it's okay, then I've got the value. This is basically like just using a regular programming language. I just get the value. But if it's not okay, I'm going to panic. The program will crash, and I'm doing that for the reasons of safety. Like we've gone past a point in the program's logic that I clearly understood, and I don't want my program to keep running in some weird, undefined way. So I'm just going to crash. The other thing we can do with this, so if we don't unwrap this, let's call this result descriptor, and we'll say, let me close that over there. Oh, and GitHub Copilot helps me again. So we could say, let's let the descriptor be the result of matching on this enum. Remember, result is that enum of okay or string. And then we'll just go through the branches. If it's okay, we destructure out this value and we return the value that we actually want. And if it's an error, we'll panic and we'll print the error. So let's try to run this. Let's try to run this again. Match is exactly like a switch statement. Yeah, the matching on enums is really nice in Rust, and it has some powers and capabilities that aren't very common in a lot of languages. Switch statements, but yeah, it was pretty similar. Yeah, so it still says the environment variable not found. So I don't know what I'm doing wrong, to be honest. Does anybody have any ideas?
I might.
Yeah.
Can you try to import that variable from the command line and running it? Just do export wallet descriptor and the string, and then seeing that the .env library picks it up.
It's working for me.
Well, that worked.
Yeah.
Can you do this? Can you export a file? No. I thought I did source.in. This is literally the reason that I use this. This .env. Also, see, I already cheated up here too. From file name is also return a result of a path. Well, this is a sad start, but wallet descriptor. Let me look at this one. We got the descriptor in var wallet descriptor. Oh yeah. Okay. I didn't copy and paste enough code. So let's look at this. I believe this is confusing me. This function adds some paths, and then this function actually, this is why I always look at the examples directory, because they'll let me know about this. I think this is what actually actually loads them. There we go. Value line parse. So we got a new unwrap failure. All right, hey, that one didn't crash. So what this OK does, I don't know why it didn't work with unwrap, but yeah, we've got our descriptor now. That's exciting. I just got rid of that just to remind myself that these are from this .env library. Like this isn't some function I wrote. Like this is in the .env space namespace. And I could also, I could also get rid of this one and just use it like that. All right. Hey, we've got some working code. This is pretty exciting. Let's see. So let me go back to my to-do list. We read the descriptor. Yeah. Okay. We can also add anyhow for handling the error. So we instead of doing this where we're going to match on the error, and instead of just doing an unwrap here, we can be a little more idiomatic, and we can use this question mark operator. But it says the question mark operator can only be used in a function that returns a result or an option. So what we can do is main can actually return a result. And well, Copilot's just going wild here. Now it's mad about all sorts of things. Oh yeah, so let's see. Oh, that's a good point. Okay, yeah. So we're saying this function now returns a result, which could be, but it returns a result with the empty type. And so, thank you, Ben. So we can just do that. Okay at the end. And now let's just call this descriptor. And so basically, the question mark operator is typically saying like, hey, I don't really care about this error right now. I'm just going to bubble it up to whoever's calling me. In this case, this is the main function. So this will bubble up. And I believe panic if there is an error. But let's just make this a little nicer. This is maybe a little more concepts than we want right now. But it's pretty common for writing application code to use a crate called anyhow. So if you do cargo add anyhow, and maybe actually before I import that, let me try to motivate this. We do this. Oops. I don't know why these need to be the OKs. Well, I'll just use the anyhow result and try to explain what's going on. But you see this box din stand error. Remember, a result is an enum over a result string, or well, a result of whatever the type is and whatever the type of the error is. And you see in this case, this is var error. And that different functions that you return could be from like totally different libraries and are going to have different error types. And so you can't just assume that everything's going to have the same error type. And that ends up being kind of a bit of a problem because you have to somehow convert all the error types into the same error type because Rust is so strongly typed. So the nice thing with anyhow is that you can be more generic and just use kind of magically, it will handle all these different error types. There's lots of other stuff that anyhow gets you, but that's kind of one of the reasons why I pull it in pretty easy early when I'm writing application code, just so I don't have to think about reconciling all these different error types. And so now we have an anyhow result, and all we worry about is what the type of the value we want, and we just kind of forget about what the type of the error is. All right, so we got our wallet descriptor. We're making great progress. And let me just go to the README, and we're going to add BDK. So we're actually going to be real Bitcoin developers now, and not just .env developers. So let's add another crate, cargo add BDK. If you look down here, we'll actually get in this a little bit later. When we added BDK, it brought in some default features. Uh-oh. Failed to run build scripts. Hope that doesn't ruin my entire day. This looks awful. Oh, you know what? Okay. This is, I'm gonna have to fix some settings for Rust Analyzer. So for some libraries that I develop, they need like a different compiler because they have C dependencies. When you're using Rust and it's just all Rust, everything typically just works just fine. When you start integrating with the C ecosystem, which, for instance, a lot of Rust, Bitcoin stuff uses libsecp. There's some problems compiling on Mac. And so Rust Analyzer is compiling your code to give you these nice hints and stuff. And so sometimes it will fall over. So I added these extra flags so that it would work. And I'm just going to get rid of those flags. So hopefully you didn't run into that problem. But it sucks. And this happens in Rust where you had this wonderful setup and everything was working, and then you added a dependency or you did something, and then your IDE stops being magical in IDE. And I'm very heavily reliant, maybe too heavily reliant on the IDE aspects. So I needed to fix that for myself. See if we have any. Rust Analyzer is no longer mad at me, it seems like, so that's exciting. Yeah, so index, and so now we got the inlays and stuff. Okay, so we have an IDE again. So we added BDK, and what I was saying is that BDK has some default features, and then it has a bunch of optional features. And we'll use one of those optional features in a bit, but that's all that's going on when we cargo added. So everybody's got BDK added. All right, so let's pull up the BDK website and look at the example. So this is their example of syncing the balance of a descriptor. And we're going to basically be able to pull this straight in and just do some liberal copy and pasting. But we could try to write this. Let's see. I'm trying to think of the best strategy. It's a lot of syntax to remember. So I actually really do struggle to just freely write Rust, and maybe that's an aspect of my memory. But yeah, so let's try to make this wallet. We could just start out with, so let's say let our wallet, we're making a new variable, equals wallet new. All right, so it failed to resolve. We haven't declared this variable. So we're going to import the BDK wallet. And so now we've got that up in our imports up top. All right, so now it says it's expecting 4 arguments and it found 0. And if you'll notice, we can hover over this. I mean, like in TypeScript where you can see like, hey, what arguments does this function want? But these are like a descriptor, E. Change descriptor, option E. Network is network. Database is D. Like what do these even mean? And then you'll see down here it says where E is into wallet descriptor. So that means E is a generic, and any type that would be convertible into a wallet descriptor. So what we'll try to do is we'll try to give it our descriptor and see if it likes that. So I'll just put our descriptor right here. It says the next argument is change descriptor option string. And the nice thing with the option, so options are very similar to results. So it's another enum, and it's option, it's generic over T. And it's some T if we have it, or none. So result is okay if you have it, or error, and then the type of error. Option just doesn't have the error. It's just none. So so what I'll just do is say none. So we're just not going to use change description, and that's fine. And so then which network? In this case, this is a capital N network. So that we got some type here. And so what we'll do is, I believe this is the, sometimes here. I do this a lot where you can just like I command click and I go to the actual code, right? I'm in BDK source wallet, right? So like, what is this network type? Oh, so that's a Bitcoin network constants. So this is a type from the Rust Bitcoin library. And if we click into that, it's just an enum. So we're going to want a test net. So if we put in network test net, it says we don't have that type yet, so we'll import that. In this case, BDK is re-exporting this type from the Bitcoin Rust library. This is a bit of a gotcha in Rust sometimes, where multiple libraries that have a shared dependency, it's actually very important that they have the same version of the dependency. So sometimes, like I could cargo add Bitcoin and have the Bitcoin library myself, and then I would just use Bitcoin network, and that would probably be fine. But in this case, they're re-exporting it for me, so I'll just stick with that. But that's just something to watch out for, especially when you're using multiple libraries that have that same reference. In this case, to Rust Bitcoin, you kind of want them to stay in sync. All right, so we're at 4 of our 3 arguments. And what's the last one? So it wants a database. So let's dive into this. I actually remember this being very, very hard the first time I ever used. Like, what is D? So it's a batch database. Okay, a database that supports batch operations. But how do I make one of these? How do I have this? And I never determined that myself. So let's go see what they do. Oh, cool. There's a memory database default. So we'll just use an in-memory database. That sounds pretty helpful. All right. And let's go back to our main, and we'll just pop that in there. All right. So it says the trait bound standard string descriptor template is not satisfied. The following other types implement trait. So now it's trying to be helpful. And actually, maybe it's sometimes these hints are easier to read when you just compile it. So it's compiling right now. It's compiling BDK and all of its dependencies. All right. So this is Rust trying to be very helpful. I need to declare, I need to import that memory database, but this is our big problem. Trait bound string descriptor template is not satisfied. And so I know I'm going slow because a part of me just hardly remembers anything that I have built here, but also I'm going slow because this is what it feels like to write Rust, especially early on, is you're going to be seeing documentation or errors that just might sound like total Greek. But so all of these types implement trait descriptor template. It's required for string to implement into required by a bound. And that bound, if you remember, it needs something that implements into wallet descriptor. So one thing I try sometimes, and we'll see if it works here, is call .into. And that magically worked. What that is saying is that some kind Rust programmer somewhere has wrote a function that converts strings into wallet descriptors. And so now even though I just have a string and I need a wallet descriptor, I need this very strong Rust type. If I call .into, then Rust is smart enough to find that function in the BDK library that converts strings into wallet descriptors. So that worked for us. And so now we just got one more error. Let's import the memory database. All right. So, shoot. Oh my gosh. Type annotation is needed. Cannot infer type of the type parameter E declared on the associated function new. So I'm saying, hey, I think this can be converted into whatever E is, but we actually don't know what E is. So let's look at how they do this in the README. I don't see them dealing with this. Should. Okay. But I also looks like they're just putting this string straight in here, right? But like I have a string, like why isn't that working? Yeah, I have a string capital S, yes. So I'm going to do this, and I think this is what would, can we import the impl into? Oh, there you go. Okay, yeah. Borrow of moved value. All right, if it's mad about borrow of moved value, just clone it. No, that's not going to work. Oh, it got moved by a debug. So yeah, you're right. And so yeah, so we got a few things going on here. Let's try to get. So I think one of the problems is, so Rust has this concept of the borrow checker, which means if you hand a value to a function, remember Rust is not garbage collected. It needs to keep track of the actual memory lifetime of everything so that it can free it if it's not being used anymore. And I pass this value into debug, and Rust's like, you know what? You gave this function. I have no idea what this function is going to do with this value. So I don't know if I can really access that memory anymore. So when I tried to move it in here, it's like, I don't know if that really exists anymore. You passed that to debug. So I'm going to get rid of it here. And so now this is compiling. But let's do the string thing. So if I do let stir descriptor, right? So I'm just going to do a string literal. Let's see what Copilot thinks that descriptor looks like. Sure, whatever that is, that's definitely not sufficient. But so this is called, and I can do this is a huge. I should have had this in my learning humps of Rust. Is and stir versus string. I could also do let string descriptor equals string. Oh, that's one way to do it. Sure. So so the capital S string is if you think of it, one way to think about it, and I'm probably the wrong person to really give you a really good, deep explanation of it. But one way I kind of shorthand think of it is that an answer is sort of a fixed, ungrowable array. It's like, I know exactly what this length is. It's just these bytes. That's all the string is, right? The stir is. String is like a vector. It's like it's growable, and so it really depends. I'll actually create a function. So this is our first Rust function. Sorry that it takes so long. So I don't know enough C. Does anybody know the answer? Like what the analogy is to C strings and Okay, yeah, I'll just repeat what Ben said. So the and stir is kind of like a C string, and then the capital S string is kind of like something in Java. So it's like kind of something that you typically have in like a higher level programming language. Yep. Okay. Are you doing use BDK Bitcoin network? And you should only have had imported BDK in your cargo added BDK. And you're getting, Ben's gonna look over here. Yep. What was the problem?
Okay, so Bitcoin network
Yeah. Oh, down here, yeah. Right? Because that namespace is already imported. Okay, yes. Someone asked where can you get the descriptor? So I just copy and paste the one that is on the BDK GitHub example. Because I'm not going to be able to spend it. I'm just going to pay to this one. This should be a valid descriptor. Does that work? So I just kind of still digging into this string stir thing. I've got a function that takes strings, and it's this string type, right? And so if I call this function that takes strings, if I pass it this stir descriptor, it says expected string found and stir. So one easy way to do it is that you can just call toString, right? It's real easy to turn one of these stirs into a string. Another thing you can do, and the reverse is pretty common as well, where you have a function that takes an and stir, which is our case in BDK, where they were fine with the and stir. And it now says expect an and stir and a found string. So an ampersand in Rust, it means it's a reference. So remember I was talking about that borrowership and ownership. So like if I took, let's see, let's get rid of that one. And we've got our descriptor. And we have a function that takes strings, and we'll pass it this descriptor, but we'll pass it as a reference, right? So we had descriptor is a string, but we added this little ampersand before it, and that's passing it by reference. And so what a reference means is that you don't own, I mean, it means a lot of things, and but one of the things it means is you don't own this memory. So you're not allowed to mess around with it. And so remember we had that problem before where I was passing descriptor, and I passed descriptor to debug, and I don't clone it. We have a borrow of a moved value. Debug moved that value because I passed the descriptor by value because it was of type string. But if I if I clone it right here, just like, hey, I'm not going to give you the original, I'll just give you a copy. then it's fine. But also here where I pass it by reference, I still have it down here. I don't think I even need to clone. Yeah, I don't even need to clone it. So Rust is saying like, hey, I'm gonna hand this function this thing because it wants it, but I'm only handing it a reference to it. So that means I still have it later to pass to another function. Yeah, it is partly about mutability. In fact, in Rust, by default, bindings are immutable. You'd have to make it mutable, you'd have to make it mutable like this, like let mute. So to make it mutable, but it's more about this borrowing aspect, this like lending aspect. I mean, there's a lot to it, but like a good mental model is like loaning out a book. You can, if you want to have a like a mutable version of a book. Now the analogy is already falling apart, but you really can only have one person that can change the book, right? But you can hand out a bunch of copies to a bunch of people, right? And if you had a book, right, that you could edit, but you also made a bunch of copies, what would it even mean to edit the book? Because these people have copies, right? So you can either have one person with like mutable access or the ability to destroy the book, right? Which is what's happening in the case of when I pass it to debug. Debug's like, the program's done with this value. I can just release it from memory. So if you want somebody to be able to destroy a value or change a value, you need to have this exclusive ownership. But if nobody has exclusive ownership right now and it has that capability to destroy or mutate, it means you can pass out unlimited copies by reference or in various other ways. The other way, the reason why clone is like a get out of jail free card a lot of times is because I'm just saying like, hey, let's have another whole, not just a copy, but like a whole new value that is the same. All right, so we've got this wallet, and now it's an unused wallet. I don't even know if it implements debug. All right, apparently it does implement debug. So we'll try to run this, see what we get. We got a mini script error, unexpected error while parsing key derivation path. So it doesn't like this descriptor for some reason. Has anybody else run into that? No, I got rid of the Copilot descriptor. I shouldn't. It's possible that I did something wrong on my env file. What if I get rid of these quotes? We go to, you got the one from the README. Let me look. See if I did anything different in my example project. Oh, look at that. I got that weird string escape in there. All right, so this is potentially some copy and paste error on my part. Yeah, so that's not helping anything. Yeah, it's like escaping the string at the end. Remove the what? But all
So if we change descriptor just to be one of the lowercase strings, then it should work.
The ampersand should do that.
yeah, that's what the ampersand does.
Instead of a question mark, I did an unwrap.
Yeah, that should just be the same thing. Let me look at if I did anything different in the descriptor.
Is the ampersand the same thing as the as underscore str?
Yeah, that's the same thing.
What if I source that again? There we go. Okay, maybe it's not rereading it doesn't apparently reread this env file. I still have to like source it. So that's okay. All right. So we have a wallet. Good work, everybody. So this is type wallet. So debug, if a struct implements debug, we actually haven't done anything with. There's a lot in here, but this is all that's decoded into. But let's just start using this, and we'll just kind of try to keep going. Oh yeah, string versus string, and yeah, and if you notice, we used a question mark here, right? So we're unwrapping that error, or not unwrapping. We're able to bubble up that error through anyhow result. Let's close some of these tabs. .ok, and to be honest, I don't know why this was not working with just unwrap. It converts from a result to an option. So remember, we have result and we have option. So it's basically just a way to like discard that error. And yeah, .env is doing some kind of weird magical stuff that I don't really know what's going on there. But that's one of the things with Rust that I kind of talked about that curve of I don't like this. I have a thing that works, but it's kind of sucky. Like maybe you're doing unwrap or something, and then later on you're like, okay, there's an idiomatic way to do this very specific thing I want to do. And in this case, it turns out okay is I guess they want it as an option T instead of a result T. I don't know why they designed their thing like that. Yeah. Well, so the question mark is more of me as a consumer, how I'm handling the fact that it's a result or an option. Here, it seems like they don't want if will it show me the type? So if you look at the type that this is returning, it's returning a result, and then okay is returning it to an option. And so my assumption was, okay, well, I'll just unwrap this, right? So it's not going to be a result or an option. It's just going to be the value, or I'm going to panic. And so when I try to do it like that, of course, it just works. so nobody knows anything, and whatever. This is what it looks like when I copy and paste from them. So I'll just stick with that. Just one of life's little mysteries, I guess. So let's return an address from our wallet. So let's pull up BDK's example code. They've got yeah, it's pretty dang easy. Wallet dot get address. So this is just if you notice, so there's this syntax with these colon, and then there's a dot syntax, and they're kind of similar. But anyways, we have a wallet. Like, what methods do we have? This is when it's nice to have an IDE. So there's a lot of things we can do. get the balance, but right now we don't have a so we say let balance equals wallet.get balance. Oh, we did it again where I tried to debug that wallet, borrow moved value. So let's get rid of that. And so let's just debug out that balance. See what we get. It should be none because we don't have a way of, yeah, the balance is empty. If you notice in their example, they actually sync their wallet with the Electrum blockchain. I don't, because this example has been in here, I wonder if it has any fun. So let's just do this. I'm just going to copy and paste. I need to get this window over here. Okay. So let's get this blockchain. And so let's see. We want to wallet.sync, and then we'll pass this blockchain by reference. All right. Oh, really? Oh, sweet. Okay, so we're going to pass this. You see, it wants a reference to this B that's generic over various types of blockchains. So we're going to pass this blockchain we created by reference. And then there's some sync options. And in this case, we can use default. And that was good enough for us. And we got some more types we got to import. I just imported sync options, by the way. We'll import the Electrum blockchain. All right, so now what we'll do, so we've got a wallet. We sync that wallet. We get the balance of the wallet, and then we're going to debug print out that balance. We run that. So it's syncing. All right. We got some sats. Well, we don't have the sats because we don't know the private key. But somebody has some sats, some testnet sats. So that's great. All right. So let's print out the first address. What was it? So let address equals wallet dot get new. No. Just you get the private key? That doesn't seem very... Okay. I'm being trolled by the audience. That's good. That's good. All right. So we got another type. So we're going to call this get address, and it takes this reference to self. So this is the difference between like a method with these like colons on it versus like a method with this dot on it. Like the dot methods are things that typically are things that take like a reference to the self being this object that we created up here, this wallet. So we're going to get address, and then in this case, it's asking for an enum. Oh yeah. And in this case, so, you know, an xpub, you know, you can derive addresses based on an index. So we're just saying, hey, get a new index. And so it has its own database of the state of the wallet. And so when it'll just get the next index that it thinks is valid. So we'll get the address and we'll debug this address. We run this. All right, we got address info. So it's saying the index is 64, and this is the address. Now, that's interesting that it didn't just use index address 0, and I'm guessing that's because it synced the wallet and found that a bunch of addresses had already been used, and it didn't want to reuse those. So let's get rid of this blockchain stuff and just try to get the first address. Yeah, and we get address 0. Now, if we call that again, You can shadow variables in Rust. That's all fine. So we get address 0, address 1. But you notice if I do this again, we get address 0 and we get address 1, right? So we're not saving any state, so we don't know which index we are at unless we would sync to the blockchain, and then we could look at what addresses have been used. This is a pretty good spot. We can do a lot more, but I wanted to see if anybody has any questions about where we're at right now and what we've done so far, and anything that is just like, I wrote that and maybe it worked, but it was gibberish. And any questions? It's all really, this is just obvious and straightforward. Ben wants to know about lifetimes. That's Tony's going to explain those next week at the LDK workshop.
So is it better just to put question marks everywhere, or just to actually have a dot expect to kind of error handle? Like, how often do you use the question mark at the end? Like an error message.
Yeah. So the question is, how often do you use the question mark versus like a dot expect? So a dot expect is a lot like an unwrap, actually. So dot expect will panic if the value is not there, just like an unwrap is, except you like why I think the typically when I use expect in Rust is I've done some other validation myself and I just know I've got this, and I'm fine that the program crashes if it's not there because I expect it to be there. So like if I have an unwrap in my code, like before I like make a pull request, I'm going to fix that to typically handle the result or the option. But if I'm absolutely confident that unwrap is not going to fail, then I'll write it as an expect and say like, here's why I think this can't fail. And if I don't have a good reason why I think it can't fail, then I need to handle that result or that option, which question mark is saying, let's just bubble up the problem to the caller. The caller is going to call me. Let's see. Like let's make a function called setup. And it's going to return a result. Anyhow, result. So this is going to do all of our setup for us. Remember, it's saying it expected a result, this function to return a result, and it found nothing. So we'll just return OK. You can also, by the way, in Rust, you can type return, but it's idiomatic to just, this is implicit return. So now we'll just call that setup function setup. And actually, we don't want to just return OK. We want to return this this descriptor string, right? So instead of that empty tuple, we'll say this is going to return a string. So now if I save that, it'll be mad like, hey, you're trying to return an empty type. But we'll return the descriptor. All right. So we're still doing this question mark in here, right? But what this is saying is that if this is an error, I'm just going to bubble up that error to the caller. So now I need to handle it here when I call setup. So I'm going to say let descriptor, because that's what we wanted in the first place, equals what's returned from setup. And now you see we're mad because I'm trying to pass this reference to a string here because I have a reference to a result because setup returns a result. So anyways, I can unwrap that. Now I've got the value, but I'd panic if it doesn't work. Or I handle the error here, which is a result, which it bubbles up to the main function. Or the other thing I can do is I can match on this, remember? So let's do this one more time just because it's really good conceptually for what we're doing. If it's okay, so like, this is the destructuring syntax in Rust, which gets used a lot. In this case, so I'm basically like, I get this out of the OK as a value. and I just structure it out, and I just return the descriptor. And then this is one of the things, I don't know how many languages have this, where this is a switch statement that is returning a value, right? This match actually can return a value, and I can assign to it. And then if it's an error, we'll just handle the error right here. That's a good point. Yeah, so someone pointed out that I'm basically silencing, ignoring this error. I'm saying that this is okay. Everything's okay. This will, I think this will return out of the function. That returns to main, and then, but what is this descriptor? But you can't have it be void. So this return will stop main. Yeah. So this function won't continue because this has to be the different match arms can't return different values. So you see this arm is returning string. Error either needs to basically totally fail, or it needs to return the same thing. That's a good point. Yeah. Let's see. Let's panic. Must be a string literal. That's another way to say like an answer. All right. And then at that point, this is an unreachable because you can't, the program, it knows it's not going to keep going. It's not going to get to this okay point because it panicked. Is it common to return a result okay or error? Yeah, I mean, the way I typically do it is I write the function, just returning the type I want, and I start doing whatever logic I need to do. And then I realize oh, there's something in here that could fail, right? So let's say we don't want to return a result. We just want to return a string. I don't want to burden my collaborators with always having to handle this error that my function is returning. So it could potentially return. So let me handle this. So let's say, so we've got this descriptor, right? And we can't use the question mark anymore because this function doesn't return a result anymore. So we'll take this, and then we'll say, we'll match on that descriptor. And then if it's okay, we'll return the descriptor. So that's good. And if it's an error, we'll just put in a default value. The fallback will be, I'll just return, sorry. You saw that mismatch types, by the way. It's like, hey, this thinks it's going to return string, but here it's not returning anything. So let's just return a WPK. Yeah, let's Copilot's fake descriptor, convert that into string, and then get rid of this. All right. So now we have a function that doesn't return a result anymore. It always succeeds. And we know this at compile time that this is always going to work. And we got the descriptor. And if we fail to get that descriptor, right, because this is the part of the problem, the part of the code that we're not really sure about. Like, what if Paul fucks up and he doesn't do something right with his .env? I don't want his first experience with my program where it crashes. So I'll just handle that for him and return a default. Of course, that default doesn't actually work, but hey. And so here we could just say let the descriptor equals the return value of this setup function. And now we get a little warning about unused variables. So you can, in Rust, if you're ignoring a value here, I'm ignoring this error. I didn't deal with it, so you can just replace that with a underscore. Cool. All right. I think what we could do is add a little persistence. We had that thing where, you know, each time we run this, we get the first and second address, unless we do the sync. So I hate to do this to you because it's going to change pretty soon how storage works in BDK. But I wrote this a few weeks ago, and I'm just going to give it a shot. So, oh yeah, I've got a lot of things going on here. So yeah, we're going to use a SQLite database. And so the first thing we need to do for this, let's see, I think I have this in my notes, right? I didn't just put myself in a total, yeah. So let's make it so the app uses SQLite to persist. So that means every time we run this, we should be getting a new address. So now we're going to go back to cargo add, and we're going to add a feature. So if you cargo add, and then you say features, SQLite. One thing that's really common is libraries will leave off maybe like some serialization stuff that they don't know that you'll definitely need, but you always end up using it. So you'll add that as a feature potentially. So in this case, I added the feature SQLite, and if we look at what that does in the cargo toml, instead of just having the version, we have the version and we have this optional SQLite feature. So let's, now in here, instead of using this memory database, we're going to use the SQLite database. I don't know what the actual syntax is. Copilot thinks it's open, but let's see what it actually is. New. So we'll pass it a path. All right. So let's call this PayPal.db and get rid of this memory database. All right. So now this happens a lot in Rust. So I just want to warn you about it. You see this as ref path, right? So Rust again is very much trying to be to defend you with strong types. So in this case, you can take a string literal, and that can be converted into a path. So that's fine. But you could say like let my path equals PayPal.db, right? And what we'll do is you could do Rust infers types, but you sometimes you might want to be a little more explicit, and you can actually say, here's what the path, here's what the type this variable is going to be. And so I need to import that. So this is part of the Rust standard library. So now it says this is a mismatch type, and I expected a path, and I found a reference. So we'll say path new. Found out. And this is great. This doesn't return a path. It returns a reference to a path. Which is, I have no idea why they chose that. But that should actually, let's see if that works. I think they wanted a path buff. So that so that also works. So here we're saying we actually want a path. And anyways, so like it's something to kind of keep an eye out for, like when you're passing strings around in Rust. Sometimes it can be helpful to kind of elevate them to like the real type. Like same thing could have happened here. Instead of just trying to pass this descriptor in here and hope that they handle it, like you could parse it as a wallet descriptor yourself and make sure that you have the right type before you like proceed with trying to make this wallet. All right, so we've got this database. I don't know if is this just going to work? I'm trying to remember what else we need to do. I guess I could look at my README. Oh, sure. Yeah, that's what I did with cargo add, BDK, features, SQLite.
SQLite to your name at the top.
That is database, colon, and then before we were using memory database, and now we're using SQLite database. Let's get rid of this guy. I think this might just work. You'll notice though, all right, we got 0 and then we got 1. We try it again. Now we get 2 and 3, 4, 5. So we have, I mean, that kind of, not every experience you ever have with SQL is going to be that straightforward, but yeah, we have this database. I can show you. Look at this SQLite viewer. Finder. There's a few different ways to actually deal with databases in. All right, so we've got yeah, this is really all our wallet is, other than our descriptor. All the state we're actually saving is this this last derivation indice. So just trying to watch out for address reuse. And if you remember the example I showed at the start, I'm using that state to make sure I'm not reusing addresses that I'm showing. All right. Well, that was maybe too easy. Let's see. Let's see. So I don't know. So we could add a server to this that returns an address on each front. I think one thing that would be really nice. Yeah, let's give this a shot. My thought was to try to go to like 2-ish. Is that okay with everybody? All right. I'm also happy to just answer just more generic Rust questions, but this is a lot. There's going to be a lot more complexity here, and so I might fuck it up, but it's not. This will also expose a lot more stuff. So yeah, like I said, I really like examples. So Axum is one of the server libraries in Rust. Tokyo is one of the popular async runtimes in Rust. And so Tokyo is winning the async runtime popularity contest, and therefore their blessed web server is potentially winning the web server popularity contest. So let's just look at their hello world, and we can just copy and paste it. Yeah, but basically we're going to have an async program now, and that needs what's called an async executor. And I'm not going to dive too much into that, but just know that means we're going to decorate our main with this macro that will add an async executor. And then we'll also say that this is an async function now. And now we'll magically be able to do like .await kind of stuff. So we're gonna build an application. So we just create this router, we choose our address, and then we bind our server to the address, and we serve this the app. I don't know what app. Where's the handler? Oh, that's right here. That's in the Git. So we're adding to this router a Git method on this route. And this is the actual handler. So this is notice this is a function. What's being passed as a value here. So that means this function is going to be called when Git is hit. So anyways, let's just copy and paste this in. and just give it a shot. And yeah, this is Axum examples. Hello world main.rs. All right, so we'll create the wallet, and then we'll actually, let's see, we want this. Okay, let's say and we'll just comment this stuff out for now. So it's going to be mad because we need to add Axum. I think I put in here, we're going to add Axum. We're going to add Serde, which is serialization, deserialization, which is basically we're going to turn types into JSON so we can send them over the wire. Serde, and we're going to add a feature to Serde, which is derive. We're also going to add Serde JSON because Serde doesn't actually handle JSON out of the box. I've done this for basically almost every Rust program I've ever wrote. I ended up having to add Serde, add the derive, add Serde JSON. So maybe someday this will be like part of the standard library. Rust kind of has, so first I'm adding Axum. Then I'm going to add Serde, features, derive. We're going to add Serde JSON. We're going to add Tokyo. I'm just going to take all the features of Tokyo because I don't know which ones I can live without. And now we have an incredibly bloated Rust program, probably with over 200 dependencies, something like that. So I'm sorry. That's definitely a Rust problem. And then I'll just go through all these and import. Oh yeah. In this case, there's a bunch of different ones. I believe I'm going to want Tokyo's socket address instead of the standard. So Rust standard library was all written before async was even invented for Rust. So everything in Rust standard library is designed for a synchronous context. I don't know how much this matters actually in a socket address. In fact, it's very possible that they're like re-exporting one of these, but usually err on the side of all right. So doesn't like that socket address, but let's add that macro to the top. Let's put this over in this desktop. So this is the Tokyo main. So this is saying we're going to have an async main function that will have this async runtime. If you think of like a simple way to think of the async runtime is like it's kind of a dispatcher. It's going to kind of do the scheduling instead of manually doing like something like threading or something like that for multitasking. You're going to hand off these async jobs to this executor, and it's going to do something magical with them and keep your program going. Let's actually see. Yeah, I got it wrong. They actually use the standard net socket address instead of their own. And I don't know why that is, but we'll switch that type. And now it just wants to have this handler. So we'll write this handler, or we could copy and paste it. So we'll just put a function out here and import Axum. So this is our import block now. I'll get rid of the ones we're not using. Oh, we're going to need address index. We got Axum, which has a router, and we have the standard socket address. So those are things we added. And apparently need to import Git as well. So that's routing Git. All right, so now we actually, I think we have a web server built. So let's see what happens if I cargo run this. Oh, we're only up to 172. We're good. Only? All right, it says it's listening on 3000. So let's hello world. All right, we've got a web server. So we can, what we're going to want to do, and I'll look at my previous project for reference on this to make sure we get there before 2 p.m. But we want to return, well, what we want to return is something that implements into response. And basically, JSON implements into response. So we're going to create a struct that we can convert into JSON, which Axum can turn into a response to a request. So let me make sure I get this. Yeah, let's see. I don't know if this will actually work with anyhow. So remember, just like BDK accepted something that could be converted into a wallet descriptor, Axum like handlers are things that can be returned into an HTTP response. All right, so that's still compiling. So let's make our first struct. I can't believe we've gotten this far without actually making a struct. We've just been doing some enums. So let's call this address response. So if you're not familiar, structs are pretty common in languages like C and C++ and stuff. TypeScript has like interface or type. It's the shape of the object. It's not the thing itself. It's what this object always looks like. So let's say we're going to return a string, and let's also return the index. As a very new programmer, when I started with Rust, these number types were pretty tricky for me. Basically, you have ints. So like, oh, there we go. That was helpful. Also, U size and I size. So these are the size of how this number is stored in memory. Obviously, smaller numbers have a lower cap of how big of a number they can be. U size and I size are the memory size of the machine you're running on. So again, this is kind of bare metal stuff that you don't typically have to think of in a lot of languages. And you just kind of get comfortable with it in Rust. It's usually pretty safe to just, work with like a U64. That's an unsigned integer. So that means no negatives, or an I64. Or you can use usize, isize, but you're probably going to end up coming across libraries that are trying to return you a U16 that you want to convert into a U64, or a library that wants a U16 and you have a U64. And at that point, it is actually something that could fail in your program. Because I've actually seen there's a huge bug in a JavaScript library that just didn't contend with the fact that there is the integers only get so big, and they just, I think they started overflowing or whatever. Rust is going to make you deal with the fact that this U64 might not fit into this U16. So what are you going to do about it? And then there's also floats, F32 and F64. So anyways, we took a 32-bit unsigned integer. And so this is our address response. Oh, it doesn't like this? I might do a little, let's see. It says, consider Axum debug handler to get a better error. I thought that was working just a second ago. Didn't we run that? So we're getting some nasty errors, and this is part of, you know, what's really challenging about, so handler's not implemented for future output result implement to handler. So they're recommending this little macro to improve the error messages that they just gave me. So let me try that. What's that? Where, what would I await? I think they should be awaiting that for me. Like you're saying like that? Yeah, but see, it hasn't even been called yet. So like Git should, let's see what this macro does. Not fine, debug handler. Might have to add a feature. Axum. Debug handler. Is there a feature flag for this? No idea. All right. I can't get this to work. So in the interest of time, I'm going to look at my old project and what I did and the type signature. It has this concept of an app error. So we make our own error that wraps in. I kind of vaguely remember there being some weird stuff here. I believe I stole this this style of doing things from one of the Axum examples. So this is so we have this struct here that we're hoping that we get to use if we can get things to compile. This is just more like a type alias kind of, or it's a struct that just wraps a value. Remember, like OK wraps a value. It's very similar to that. So we've got this error that wraps anyhow error, and then I remember there was some weird thing that we implemented. This enables using a question mark on functions that return result anyhow error to turn them into result app error. That way we don't need to do that manually. So this is some amount of, I mean, this is what fighting Rust looks like sometimes. Is Rust is pretty confident of what type it wants, and it's not going to budge unless you can convince it that you're doing it right. And Rust, it might be unfair or incorrect in some sense, but if you want to get your program to compile, this is why I spent a lot of time looking at examples and also just searching code on GitHub. Is like, how did someone do this? And it's still not happy though. So let's see what else do we do in here? Oh, and then I tell Axum how to. We get a little, I'm not going to dive into traits today, but we're implementing this trait, right? Remember, we've been talking about the into alt descriptor, into response in this case. This is a Rust trait that has a function. So a trait is similar to a struct. A trait is like a shape of, here are the methods that should be implemented to adhere to this trait. So in this case, there's just one function called into response. So the thing we're fighting right now is we have this result with an anyhow error in it, and we're trying to get Axum okay with this type signature basically. I believe that's all the tacky stuff that I've been doing right now is what is actually getting us. But it still doesn't impl. think it's because this is. Yeah, I don't know. Let's just look at this type signature until we'll figure it out. Oh, and they're just using the regular result. And it's happy. So sorry about that. Yeah, that's obviously I did a bunch of random things, copying and pasting. And sadly, that's kind of the state of my level of Rust knowledge right now. There's definitely a lot of times when I just don't know what I'm doing, and I just kind of fight the compiler and look at a bunch of examples until I find something that works. But now we finally have something that compiles, and so what we want to do is actually return this address. In the interest of time, I'm just going to make this address myself and not use BDK. And in my actual example code, it shows kind of how I link this all up. So what we want to do is we're going to create this struct. So in our handler, let's say we'll create this response, and you can this is the kind of like the struct literal syntax. And if you can impl, like you can have like a new method on your type for creating a new one, or you can just make this literally like this. So now if we try to return this here, so we'll say we're going to use Axum's JSON, and it's going to convert things into JSON, and we'll put this response in here. But it complains. It says serialize is not satisfied. And so that's the kind of the whole thing with Serde. So this is something I hadn't really experienced before Rust, and since then I've seen this in a lot more programming languages. So maybe it's something you guys are comfortable with. But the idea that just because you have a piece of data, I mean, even in JavaScript, you have to take an object and you have to like JSON stringify it. You have to convert it into whatever the actual format you want it to be. And so the way that usually works in Rust is with Serde, and in this case, serialize. And this is a derive macro. So this means that Serde has written stuff so that it can generically implement the serialized trait for whatever my struct is, as long as every member of that struct also implements serialize. So now we should be able to serialize this. And so now the compile error has gone away. So if we run this again, and we go here, and we got our fake struct. So yeah, if we had a bit more time, if I was a little less bad at this, we could get that talking to BDK and getting these addresses from BDK. But yeah, I just threw in a lot of things right there. So I think we should maybe just talk through anything that's confusing or magical in here. There is a lot of magical stuff just in async in general that can be kind of hard to have a concept around. But if you want to make a web server, you're probably going to be making things that you're not going to fully understand for a while. And it's unfortunate, but that's kind of how, that's again, the stage I'm at with Rust and async. Yep.
I want to throw in that the Axum docs are excellent. They're a little bit thick, but they're really well written. So.
Axum, the comment was Axum docs are excellent, a little bit thick, well written. Yeah. Tony asked, what's a runtime? I explained it earlier a little bit, but yeah, this is the idea that Tokyo is this async executor or runtime. So when you have an async function, for instance, this handler, right, is async. So you like a real loose mental model you can have is like, I'm going to spawn a thread that's going to go do that. So I'm not going to block my main program. I'm going to run this handler. It's going to do whatever it needs to do. And then it's going to signal back to my program, hey, I'm ready. And that's what happens when, I don't know, let's see if we do await. Yeah, we await right now on this server. And so whenever, and I'm sure under the hood, Git ends up calling await on this handler. They've got a whole macro thing. So that's going to be really hard to read. But so the async executor's job is to spawn these little tasks. It doesn't typically actually use threads for them. It might use a thread pool. There's a lot of different strategies for how async code gets run in Rust. But it spawns these tasks, and then when it receives this message that that task is ready, then it brings it back into the main thread and returns the result or whatever needs to happen next. So, the idea here is that you can actually have a very high performance web server doing a ton of stuff all at once, and you don't have to necessarily think about threading or how you're going to make that multi-core or whatever. How does it compare to Node.js? Node.js, I believe is pretty much single threaded. It has, so in JavaScript, you have this, it's kind of a similar concept of this kind of async executor, but the way it all runs, it ends up actually being single threaded in the long run. Is kind of how I understand it. There's I'll show what it's called. There's some, the JavaScript runtime I would say is definitely different. I do think there was a lot of influence. I think the async and await like verbiage and stuff like that from JavaScript is also kind of how things are described. I guess in JavaScript you let value equals await async function, right? So that's the JavaScript style. Here you call dot await as like this method, but you don't. There's not like a paren on it. But the function declaration is similar, where you precede it with an async thing, and you can always do async things inside of an async function. But for instance, if this function main isn't async, I want to be able to do, like, for instance, this await in here, because I'm not allowed to do async things. I don't have, and if I don't have an executor, same thing. The Rust, because this wasn't part of the original Rust language, the Rust language really doesn't know what to do with this async stuff. As far as they've gotten to standardize Rust stuff is these keywords like async and await. There's also this whole concept of like basically futures. Like there's types for all of this stuff. If you look at the type signature of handler, because it's an async function, it's actually a future, and so that's how Rust has this kind of type safe thinking around all of these things. The big gotcha is there's a really good blog post about this called "What color is your function?" And the idea of color functioning, like basically you have the red functions and you have your blue functions. Like you have normal, synchronous, standard Rust code that you're going to learn in the Rust book or whatever. And all of a sudden you have these other functions, async functions. Like async functions have some rules that make them, in some senses, relatively incompatible with some of your synchronous stuff, or vice versa. So it becomes a pretty big cognitive load. But the Rust community is also taking it very seriously how unergonomic and how much of a learning cliff there is right now. And they're working pretty hard to improve that. And so I'm optimistic, and I have seen a lot of improvements just in the past couple of years. But I think it's definitely one of the hardest parts of Rust. And it sucks because if you want to make a web server, you're probably going to start using async stuff. So yeah, read the Axum docs and hope that they can guide you. Any last questions? Thank you so much for coming here. Hope that was helpful. Oh yeah, I want to do. Let's see. I had a bit of a review actually. I just remembered. Do we remember what this means? Option T. Yeah. What is it?
Option T, it's basically if you think of like in JavaScript, there's like null and undefined. Option T is the concept of a maybe. It can be some or none. And it's an enum that can represent, so you might get some value back or you'll get no value back, which is none.
Perfect. Result. Anyone want to take this one?
Okay or error?
Okay or error. Yeah, so a lot like an option, but also there's an error value. What is it? Pass by reference. Oh, one more. Oh. What's this name? Actually, I don't know the name for this now that I think about it. I put it on the slide.
Maybe?
Bubble it up. That's how I think about it. Yeah, bubble this up. It only works inside of a function that does return a result. Last one. Macro. So like is print line exclamation mark, because it's a macro. And that's it. Thank you so much.
Paul, can you pull up TabConf?
Yeah.
I talked to Tidwell this week. He had mentioned that if you guys want to do any kind of panels or anything like that, they have a GitHub down there. I think I saw Tony sign up for it too, but they're doing a new thing now. If you go to issues, Paul, you can start putting panels that you want to see or ones that you want to put together, and then they'll kind of source. They're doing like this open source way of doing a conference this year, which I think is pretty cool. So I definitely want to bring that up. If anybody's interested in going to Atlanta, this will happen around September. And I think tickets are like $100. So it's definitely a high signal event. There's Tacky and Lightning workshop. Yeah. Round 2. Oh yeah, there's that one too. I think they're also doing like if you just do thumbs up or rocket ships, it'll get voted in. And people are putting I think I threw something down there too.
This is sweet. So it's going to use actual Rust Bitcoin. So that's like a layer lower in the stack. We were using BDK. Tony's going to do LDK. But Rust Bitcoin is the kind of common library underneath both of them.
Cool. Yeah. And then Tony's doing an LDK workshop next week. So yeah, definitely sign up for that. Thanks, guys.
Thank you.